afternoon. Good afternoon and welcome to today's episode of Science Sundays. I'm John Beacom and I'm representing physics and astronomy on behalf of a larger committee all across natural and mathematical sciences, social and behavioral sciences, and arts and humanities, all parts of the College of Arts and Sciences. So within arts and sciences, what our faculty try to do is push the frontiers of scientific discovery, to understand the complexities of our modern society, and to nurture creative expression. And of course, a big part of why we do that is to share that with students. But another big part of why we do that is to share that directly with the public. And Science Sundays is an important part of that. So for today's episode, we have Professor Robyn Wilson. She is a professor of risk analysis and decision science, and she's the acting associate director for the School of Environment and Natural Resources. She works on an astonishingly broad range of topics, including large carnivores, risk perception, climate change, wildfire evacuation decisions, fisheries, weeds, and much, much more.
That's weeds you pull.
Yeah, weeds, like dandelions, right? Her expertise is broadly sought, including by the U.S. National Academy of Sciences, which is the premier scientific society in the United States. So without further ado, let's welcome Professor Wilson.
All right, can everyone hear me okay? I hear a microphone, I hear the speaker, so we should be good. Well, first of all, I'm gonna start my timer here. I have a tendency to talk for way too long. So I'm gonna try to keep an eye on the time and make sure we have time for questions and engagement at the end. But thank you all for being here on this cold Sunday. Thank you to John and the organizers for inviting me to participate in this. I'm really honored to be here. Being in the School of Environment and Natural Resources, being in our College of Food, Agriculture, and Environmental Science, being at OSU, which is a land-grant institution, which means we want to get science into the hands of the public, it's very important to me to be doing these sorts of events. So I'm excited to be here and to be a part of this effort. So you already heard a little bit about me. I am actually a social scientist. So if you came here hoping to hear a climate scientist speak, I'm gonna pretend to be one, like play one on television. But my work is really around how humans adapt to climate change and to climate exacerbated hazards. So I do a lot of work thinking about how individuals are managing these risks that climate is posing to us. But in doing that, I've collaborated with and engaged with people over time who felt very passionate about packaging what we know about the evidence for climate change into very public-friendly talks. So over probably 15 years ago now, in a partnership with Columbus Public Health, we developed a presentation. This is probably the 20th iteration of it, but developed it in an effort to just be available to community groups, to people who wanted us to come in and just talk about what do we know about climate change? What is the evidence that it's happening? What's the evidence that humans are causing the patterns that we're seeing right now? What does it really mean for us on a day-to-day basis? And importantly today, what does it mean for us in Central Ohio? And then at the end of the day, what can we do about it? And so we developed this presentation, and that's what I'll be sharing today. So while it says, climate change in Ohio, what should you do? I'm not gonna tell you what to do. I'm gonna present you with the evidence, the best available science as to what's going on when we talk about climate change. I'm gonna hopefully provide you with some resources if you're interested in learning more or taking action. And at the end of the day, it's up to you and your level of motivation and your ability to take action that will drive what you do coming out of this. But thank you again for being here, and I'm gonna jump right in. So I don't know how many of you, and it's a little hard for me to see with the bright lights, but how many of you, when you hear climate change, these are the types of images that come to mind? Just raise your hand. Fair number of people, right? So this is a real failure, I think, of the climate communication community for having this be often the first images that come into your mind. Why might that be? Not that we don't care about melting ice sheets, not that we may not care about polar bears losing the ability to hunt because of the lack of sea ice, not that we don't care about people in faraway places who might be struggling because of drought or food insecurity, but because as humans, and again, remember, I'm a behavioral scientist, so a lot of this talk is to really also empower you to go out and have conversations with others about climate change. As humans, when we hear about things happening in faraway places to people who are not familiar to us or similar to us, we are just not that motivated to take action. So while this might be the series of images that come to mind and they are important problems we're facing, I would like to challenge us to kind of zoom in into our communities, hence the title of this talk today and talking about what's happening here. These are all photos from across the United States, right? We don't have to go to the polar ice caps. We don't have to go to other countries to understand how climate change is impacting us here in the United States. We are dealing with more frequent and severe wildfire than we ever have before, again, in human civilization. We are dealing with flooding, and for our area in particular, this is a real threat associated with climate change. We are dealing with drought. If you have traveled out near Vegas, I remember years ago flying over into Vegas and seeing what was going on with the recession of the reservoirs out there. It's disturbing. Heat waves, living in a city, one of the biggest threats to humans associated with climate change is the heat. It's the heat waves, especially in cities where we have these heat island effects. And so I would challenge us to start to zoom in from our vision of what climate change is doing globally to what it's even doing here and why should we worry about that here in a more local way. And even further, these are images from Columbus and from Ohio, right? So I actually do a lot of work on water quality and thinking about how we're making decisions in agricultural landscapes that, in addition to climate change, then influence the quality of the water bodies that we recreate in, that we drink from. And climate change is exacerbating the frequency and severity of these harmful algal blooms that we see in Lake Erie and in a lot of our inland lakes around Ohio. This is a picture of flooding in Findlay. I grew up west of Findlay, Ohio, on a farm. And Findlay deals with a lot of flooding issues due to development in areas where maybe we shouldn't have developed. We've taken away floodplains from rivers who are used to having that space to deal with that ebb and flow. Something that a lot of people are getting more and more concerned about here are vector-borne diseases. So we're seeing ticks move further north as it gets warmer to places that they didn't used to be, and they're bringing disease with them. And I'll talk more about some of that. And then something that I got several alerts for the last couple of days are just severe weather events, right? So I don't know how many of you were getting, I think AEP was sending out the heads up, we're expecting severe weather. That's just gonna happen more frequently and with more severity over time. This is an example from a windstorm, and I want to say this was maybe in Clintonville. So I really challenge us to start to zoom in, because again, when we start to think about the claims that are out there around climate change, we might even buy into the evidence that climate is changing. We might buy into the evidence that humans are causing it. We might buy into the evidence that it's bad for people, but if it's not bad for us, we are not motivated to do anything. So if you want to have these conversations with other people, you really have to think about what is that thing that they value that's being impacted by climate change? And how can we think about those impacts and trying to avoid them as we move forward? So as we go through the rest of today, I just want to talk about kind of 5 key beliefs that we know from climate communication are critical to engaging people in climate action. So there's been a lot of research on how do we talk about climate change to people. And what we know is people who take climate action believe 5 things. They believe that there's a scientific consensus around what's happening with climate change. That is actually called the gateway belief. If you don't believe that, the rest of it doesn't matter. So first and foremost, you have to believe that. Second, you have to believe that climate change is happening. Interestingly, when you look at public opinion data, hardly anyone denies that it's happening. You can sit here and think back over your lifetime, raise your hand if you have noticed that things have changed in the weather. Raise your hand. If you are my 9-year-old, he is very upset about the lack of snow in Central Ohio. We know this, right? Lots of people know this. Where we start to see more differences of opinion is on whether or not this pattern that we're seeing is caused by humans. So I'll talk a little bit about the evidence we have for that as well. The third thing, which again, I think when you hear climate science talk, we don't often hear about the impacts. We don't hear about the solutions. We hear about the fact that it's happening and people are causing it. But we know that people who take action also have to believe it's bad for people. And like I said below, have to believe it's bad for you. Or perhaps if you're a really sort of other-minded person, you'll be motivated by those impacts to others as well. And then at the end of the day, we have to believe there's something we can do about it. I don't know about you, but when you hear bad news or you hear things going on in the world that are upsetting, we have a couple different ways we can deal with that. And in behavioral science, we talk about 2 key strategies. One is danger avoidance, right? So we'll go out and we'll do things to avoid the danger. The other is fear avoidance. So if I feel like there's something threatening to me out there, but I can't do anything about it, all I'm gonna do is try to protect my mental health. I'm gonna pretend it's not happening. I'm gonna engage in coping strategies that take away my anxiety. And we don't want people, one, to experience those kind of mental stresses, and we certainly don't want people to feel that that's all they can do. We want people to feel like there's hope, there's possibility, there are solutions that we can pursue, and we can all play a part in this. So I'm going to essentially kind of walk through the evidence for all of these things. At the end, again, based on your motivation and ability, I'll give you some ideas for how you can go out and think about what you can be doing. And I'm happy, again, to take as many questions as we have on these topics or others related, as John said, to my wide breadth of things I think about, and in the reception after. So before I jump into kind of a survey of the evidence, a couple definitions first. And again, this was a talk built not only to help educate people about what's going on in climate science, but also to be persuasive and to address the important beliefs people should have to take action, to address some of the misperceptions that are out there. So this is one of the biggest misperceptions that we hear time and time again when you engage in a conversation about climate change. And I like this comic version of it, right? If the Earth is round, then explain this, right? If gravity is real, then explain that. If global warming is real, then explain that snow, or explain those freezing cold temperatures that we're having outside today, right? Very common argument that you hear from people. So one thing I want to clear up right up front before we jump into anything else is the difference between weather and climate, right? A lot of you may know this, but this might be helpful even as you're thinking about engaging with others. Weather is what's happening right now. It is cold today in Columbus. Climate are those general weather characteristics of a region. Ohio is typically cold in the winter, right? Typically. Doesn't mean that it won't be warm sometimes, but typically it's cold. Climate change is that trend in the weather observed in a region over a longer period, often decades is how we think about that. So Ohio winters are getting warmer, but they can still be cold, right? So even though it's very, very cold today, that does not negate the fact that the climate is changing and the pattern is towards warmer on average, right? And this is just an important sort of thing for people to understand. I like this particular video. Raise your hand if you've seen this before. Anyone? A few hands? Okay, this is a great video you can find on YouTube that's really about explaining the difference between trend and variation in statistics. And how they're explaining it is that the dog walker is the trend, and the dog is the variability. Another way to think about it is the dog walker is the climate, and the dog is the weather, right? So at any given moment, that dog is all over the place. If you have a dog like mine, this looks very familiar to you. The dog is all over the place, but we know where that dog is eventually going to be based on where that walker is heading, right? So this is a very simple sort of analogy just to help get people thinking like, yes, at a given moment, the weather might be in a very different place than the climate or the trajectory of that climate, but that's okay. That's part of science. That's part of understanding, right? Trends versus variation. So climate is the trend, the variation is the dog. I just hope that that's a visual that, again, perhaps you can use with others as you go about your life. But it helps me kind of think through those differences. So what I want to do now, so we've gotten that climate versus weather definitions as a common misperception, gotten that out of the way. The claims that are out there, and I've pretty much word for word kind of taken this off of the climate website at NASA. But if we ask this question of whether human-induced climate change is real, these are the claims that are being made by the scientific community. Burning fossil fuels has increased greenhouse gases in the Earth's atmosphere. This, in turn, has increased Earth's global average temperature since the Industrial Revolution, so since around 1900, by about 2 degrees Fahrenheit. This trend is continuing at about 0.5 degree Fahrenheit per decade. And here's the most important part. So I say all of that, and I'm sure there's people in the crowd going, well, that's not a very big change, right? This is another kind of challenge in climate communication. We hear, 2 degrees, and you think, wow, Ohio can go 80 degrees in one day, right? 2 degrees isn't a lot. The important part is that the rate of change is unprecedented, not the change itself. Has it been as hot today or as hot as it might be in the future in the world's past? Yes. Has it been much, much colder? Yes. But the rate of change that we're seeing is unprecedented. It's not the change itself that is unprecedented, but the rate. And then you add the fact that that rate of change is occurring within human civilization where we have never experienced anything out of a plus or minus 2 degree variation from the norm. So we don't even have experience with it, let alone the fact that it's happening so fast. And I'm kind of adding this doesn't come from NASA, but these changes threaten life on Earth as we know it, right? It's not that we'll necessarily disappear. It's not that the world will explode, but it's going to look really, really, really different. And some people will be winners in that, and a lot of people will be losers. And I think that's the other important piece to think about. So I'm going to walk through evidence that I hope will help you understand where these claims are coming from. And again, happy to take questions at the end. I think one of the first important things to think about when you think about those claims is this idea of the greenhouse effect. So you've probably all learned about this in some science class at some point in your life, right? We would not be able to live on this planet if it weren't for the greenhouse effect. It is a good thing. It is essentially the idea that the energy from the sun gets trapped in our atmosphere. It warms the earth. Some of that is reflected back out of the atmosphere. Some of it is trapped in the atmosphere. Earth is about 60 degrees Fahrenheit. Actually, I think 59 is the global average right now. And again, recall that we as humans have adapted our civilizations to about 58 to 62 degrees Fahrenheit on average, so a pretty small range. Without our atmosphere, without greenhouse gases in our atmosphere trapping some of that energy from the sun, it would be 0 degrees Fahrenheit and we wouldn't be living here. The problem is, and I like to use this analogy too when talking with people about the greenhouse effect, think about it's very cold out, right? So how many of you are going to go home, go to bed tonight, and cover up with a big soft blanket? Raise your hand. I am a fan of the big soft blankets. How many of you are going to put a second, a third, a fourth, a fifth, maybe a 10th on you tonight? A few people, a few people. How many of you, if you put on those 10 blankets, might wake up in the middle of the night sweating and realize it was a bad idea? That's me, right? So I start really cold, I layer up, and then I wake up sweating. This is kind of the problem that we're facing, right? The Earth is happy with that one blanket. It makes it habitable. It creates an environment that as humans we can live pretty comfortably in over much of the world. As we start layering those blankets on the Earth, which is what we're doing by releasing so much extra carbon dioxide into the atmosphere, trapping even more of that heat, the Earth is getting sweaty, right? Just like we would if we kind of overwrapped ourselves. And so I think this is a good visualization just to start to kind of understand where these claims start to come from. So in 1958, we started measuring atmospheric carbon dioxide in Hawaii at the Mauna Loa Observatory. This is really the foundation of modern climate change research. You've probably seen this curve. It's called the Keeling curve or the hockey stick. But basically, Keeling discovered there's this seasonal cycle where carbon dioxide fluctuates based on plants growing and dying. And he noticed that this trend was going up. So you see the seasonal fluctuation. But then he started to notice, this trend is rapidly increasing from the time we started measuring carbon dioxide at Mauna Loa. We can use ice cores to go back further in time and see what those carbon dioxide fluctuations have been. And what we've learned from that ice core data and then this kind of modern day measurement is that we are at the highest levels of carbon dioxide we've ever been in as a civilization, higher than we've been in 800,000 years. And if you noticed on that last picture, that rate over these last 100 plus years has been extensive, right? Extremely quick. And that is the thing that we're worried about, right? We as humans have interfered in a global system that is used to some fluctuation, but we have kind of shot it off the charts. And I'll talk a little bit about when the world was last at those high of carbon dioxide levels and what that might mean for us today. But I think it's a good way to kind of think about why we're concerned about this rapid rate of change in the carbon dioxide levels in our atmosphere and why we feel like the Earth may feel like we've put a few too many blankets on it. So the last time that we had this much carbon dioxide in the atmosphere was during the Pliocene. So I don't know how many people were around 3 to 5 million years ago. That was a long time ago. Sea levels were much higher. If you look at the eastern seaboard of the United States, it might look a little bit different. Why is that? Because a lot of it's underwater, right? So if you like to vacation in Florida or parts of the East Coast, that is not a world where that will happen in the future under current climate trajectories. We had giant camels living in Indiana. You can see there were forests on the North Pole. It was a very different world, right? So when we say this is happening, we're not saying the world has not had this before. What we're saying is as humans, we've come in and we've accelerated those changes. And we are moving the world towards a climate, an environment, a reality that we don't even know how to deal with and is very different than the world we live in today. So how do we know the current change is caused by us, right? So we can show that rapid acceleration in carbon dioxide levels that coincide with the Industrial Revolution. I can tell you that the world where we have that much carbon dioxide in the atmosphere and it's that warm is a very different world. That hasn't happened in 3 to 5 million years. But how do we know it's us, right? Well, the claim is it's the burning of fossil fuels that's producing this extra carbon dioxide, right? Transportation, cars, buses, planes, energy production, electricity, heating and cooling, manufacturing and production, right? The use of oil, coal, and natural gas. These fuels that we're literally taking from the earth and burning, and we're releasing that energy into the atmosphere, and we're doing it at these rates that, again, are unprecedented. What I think is helpful is you'll hear people say, well, that's all well and good, but how do I know that's what's actually causing that warming, right? It could be something else, right? So this is a trend of just the observed warming, the variation, the deviation we've experienced from the norm over since, 1880, since the Industrial Revolution. And some will say, okay, we've seen this observed warming and the global mean temperatures, but maybe it's orbital changes, right? The orbit of the Earth shifts and wobbles a little bit. Maybe we've gotten closer or further from the sun. But when you plot that, right, against the observed temperature change, they don't really align. You could look at solar radiation and say, well, the temperature varies of the sun, right? We're a certain distance from the sun, but maybe the sun has sent some extra heat our way. No, right? We can plot that and it doesn't align. Some will say, well, it could be volcanic activity, right? And in fact, volcanic activity can cool the atmosphere, so we might see a cooling effect of that. But again, it doesn't overlap, it doesn't overlay well with those observed changes. You can then say, okay, what if we took all these natural explanations, things that are just happening that we have no control over, and we add them up together and we plot that against the observed warming? Do we start to see any sort of correlation? No, right? We still don't. We would see a very different pattern of warming if those were the explanations. And so then we might go, okay, maybe I buy you that it's humans, right? Okay, so it's maybe not these natural changes, but maybe it's just that we have changed the landscape so much of the world that that has led to some sort of warming or cooling. Again, if we plot our changes in land use, not a good explanation. Perhaps it's changes in the ozone. Ozone up high can reflect sunlight, ozone down low can trap it. Maybe our production of ozone has shifted the climate in this direction. Doesn't seem to be the case. Maybe it's aerosols, right? These have largely been banned because of concerns. They have a cooling effect. As you can see, they're kind of going the opposite direction of the observed temperature changes. And then here we're going to look at this last thing that scientists say, I think this is probably explaining these changes. Is it the greenhouse gases? Is it methane and carbon dioxide? That is the pattern that most closely is associated with these observed warming trends. Again, we can take all of those human sources, we can put them all together and look at how they might predict where the temperature would be going. And when we put them all together, we actually start to see a pretty similar trend, right? Greenhouse gases without ozone, without land use, without aerosols would actually have us even hotter than we are. But those other things we've done as humans have provided a little bit of a cooling effect that have really led all of these kind of human disturbances to be the best explanation of that observed temperature change. And you can take all those forcings, that's what you're seeing there, where you take the natural reasons for fluctuation, the human-induced reasons for fluctuation, you put them all together, and that's where we actually really see what's going on with the observed temperature changes. So again, just a kind of, I think, simple visualization to start to understand the most likely candidate for this rapid rate of change, this increase in carbon dioxide, and the associated increase in temperatures is really those greenhouse gases. And in fact, I said earlier that one of the most important beliefs that as humans who want to engage in climate action we have to buy into is the scientific consensus, right? This is the gateway belief. And based on all that evidence that I just shared, 98% of climate scientists have concluded that human-caused climate change is happening. You can find statements on the reality of human-induced climate change from 18 scientific associations. This is the American Association for the Advancement of Science that kind of represents all scientists. They all agree with this and make this statement. And we can go beyond science. So interestingly, scientists are some of the most trusted people in society today. May not always feel that way. Trust in general in society has been on the decline pretty heavily and constantly since World War II. So trust is low overall, but when you look at who we trust, we do trust science. But interestingly, you can go outside of the scientific community and still find support for this consensus. You can go to our military. They have a climate statement about it being one of the biggest national security threats, partially due to turmoil and conflict that occurs when resources are scarce, partially due to climate migration and what that means for places that are relatively climate safe. You can go to faith communities. I just put up an example of the Catholic Climate Covenant, and you can find statements from faith communities that human-caused climate change is real and that they are doing things about it and feel that it's important to do something about it. You can go to businesses. Walmart has a climate statement. So it's not just a scientific consensus, right? We can go across other segments of society and see that plenty of organizations and communities and entities and institutions have bought into the scientific consensus around human-caused climate change. Okay, so that's all the evidence for that first part, scientific consensus that human-caused climate change is happening. But is it bad for people, and can we do anything about it, right? This is the one you might hear a little less about when you're maybe Google searching climate change or watching other things online. So is climate change bad for people? Again, a misperception that we often hear in having conversations with people about climate is this idea that these changes we're experiencing don't seem like a big deal, right? Plus or minus 2 degrees from what's normal, okay. Half degree global average increase every 10 years, that doesn't seem so bad. Again, we live in a place where the weather is all over the place. And so here in particular, I think in the Midwest and in Ohio and Central Ohio, this kind of seems very, very normal, right? This is just 8 a.m. to 9 a.m. on a given day. So it doesn't seem so bad. But remember, that's the average. So if you live somewhere where your local average is 95 degrees, each of those extra degrees is pretty darn hot. If you live somewhere where your global average is 32 and it's frozen, each of those degrees means a lot. We're seeing segments of the polar north where the frozen tundra is melting, releasing things that haven't been released in a really long time. And so these changes, while it might seem small when you live more at the global average, which like I said is 59, 60 degrees, might not seem like a big deal, but out on those extremes, they become a really big deal. So the other piece of this is that these global average temperatures have been stable over most of human existence. So human civilizations really started emerging 6,000, 7,000 years ago. And in the last 10,000 years, the global average temperature has only, again, been 2 degrees warmer or 2 degrees cooler Fahrenheit from today. So we have evolved, we have built civilizations, we have defined our societies in a world that ranges from 57 to 61 degrees, right? So we're just not used to these potentially big fluctuations. And I think more importantly, those small changes equal really big impacts. So 20,000 years ago, during the end of the last ice age, global average temperatures were about 9 degrees Fahrenheit cooler than today. And that caused the ice age. So do you want to visualize what the ice age did? It covered a lot of our northern cities in miles of ice, right? So again, 9 degrees cooler, you might go, well, 9 degrees cooler, doesn't seem like a big deal. But that covered half of the world in glacial ice sheets that are kind of hard to imagine when you think about the skylines of some of our northern cities. So again, the important part there, I think, is to realize that these small changes are big impacts. And we can think about what those small changes in the warming direction might mean for us. You might hear this phrase called the Goldilocks zone. Has anyone ever heard this phrase before about the Goldilocks zone? Yeah, this is the idea that the Earth is in the Goldilocks zone, right? If we were a little closer to the sun, it would be too hot for humans. If we lived a little further from the sun, it would be too cold. We just happen to be, right, on this planet where it's just right. And what you're starting to hear talked about in the climate community is we are kind of messing with the Goldilocks zone, right? We're kind of shifting the Earth closer to the sun in a way that, again, will make some parts of the world not habitable and will really change the way we think about daily life in other parts of the world. So what does that mean for us here, right? So I promised you that when we got into this part of the talk, we would focus a lot more on what's happening kind of in our locale. And again, you might say, well, this doesn't look so bad. So what this map is showing you is that as we move towards the end of this century, the blue is showing you what our winters will start to look more like. By the end of the century, we will be very North Carolina-like in our winters. By the end of the century, we will be very Arkansas-like in our summers. You might hear that and go, great. I am thrilled about that, right? So again, beauty's in the eye of the beholder. Is this a good thing? Is it a bad thing? I don't know. It just is, right? This is where we're heading. And so again, does this really matter? Is it bad? We might look at this and go, well, this sounds kind of nice. If you look at public opinion on climate change, the majority of people think that this is bad. So again, you're an Ohioan looking at warmer winters and going, that's great. Warmer summers, I don't know. I already struggle with the summers here. But when you look at public opinion, the Yale Climate Project does regular surveys of the US public, measuring how we as US citizens fall across what they call the 6 Americas, these 6 sort of categories of how we think about climate change. There's the alarm, the concerned, the cautious, the disengaged, the doubtful, and the dismissive. The majority of people are alarmed and concerned, right? We're pushing 60% who are like, yes, this is concerning me. Even bigger majority are on that kind of half of the spectrum that are like, yeah, like we might want to be thinking about this, right? Pretty small numbers are actually dismissive, and then even doubtful and disengaged. So if you just think about public opinion, if you polled people, this is what you would find. Most people are concerned. So why are they concerned, right? Because these seem like small, maybe deviations. They might even seem kind of exciting, depending on how you like winters or summers here. So I'm going to walk through what some of those impacts are, starting at a global level, but kind of zooming in again to what's happening here in Columbus. So global impacts. One is an increase from 30 million to 2 billion people by 2070 living under extreme heat. Extreme heat is where your average temperature is 85 degrees or higher. Right now, 30 million people live in such an environment. By 2070, 2 billion people will be living in that extreme heat condition. 2.5 miles per year average speed. That's the speed by which malaria-carrying mosquitoes are moving north into places bringing malaria with them. 210 million people since 2019. Those are people facing acute food insecurity. And that number keeps rising. Again, these are global numbers. This is kind of when we're thinking about global impact. 21% in the last 20 years. This is the reduction in agricultural productivity due to heat and drought across the globe. 489,000 deaths compared to 250,000 deaths. That's the number of people dying from heat waves relative to the number who die from firearms. So there are things that we might even worry about on a daily basis in society that are killing people, but heat is killing more people than a lot of those things. 7 times more likely, this is how much more likely children born today will experience extreme weather than their grandparents. 7 times more likely, right? So it's happening. It's happening at a global level. And again, this might concern us, but we might say, oh, we're in a pretty great spot, right? Here we are in the middle of the country. We're away from the coasts that are dealing with sea level rise. We live near the Great Lakes, which is the biggest source of fresh water in the world. We're in a pretty great place when it comes to climate. So what does this really mean for the Midwest? There's some great resources, and I have a slide at the end with links to all of this that I'll leave up during questions. But in the National Climate Assessment, of which a new one just came out this end of this past year, they talk about what some of these impacts are in the Midwest. Ag productivity under current climate trajectories will be reduced to 1980 levels without significant technological advances. This second one, I think, is a really big one for OSU people. Loss of important tree species and shifting forest types. Anyone know what that might mean for the Ohio State University and our mascot? It's moving to Michigan. So there is a trajectory that is being followed by the Buckeye tree that it will end up in Michigan. So do we want that to happen? Ask yourself that. Biodiversity and ecosystem, decreased provision of services such as water purification, flood control, crop pollination, recreational opportunities. We already see this with the water quality challenges that we experience in Ohio. Human health, this is a big one, right? So again, we've made a mistake, I think, as climate scientists and environmental scientists, often talking about problems that are far away. Everyone cares about their health, and there's been a real effort to reframe climate change and its impacts around impacts to human health. So human health threats will lead to increased loss of life, worsened health conditions, and economic impacts in the billions of dollars. Transportation and infrastructure, the cost of adapting our urban systems, stormwater in particular, due to these big rain events that we're seeing more and more of. And these frequent and severe storms will exceed $500 million by 2100. And I think this last one is really important, community vulnerability and adaptation. Communities already at risk will be even more vulnerable to these things, right? To flooding, to drought, to the urban heat island effects. And so we have a real question of equity and justice here, where there will be winners and losers. There will be people who will manage this fine, but the majority of people will not. In Ohio, what does that mean, right? So that's the chapter on the Midwest from the National Climate Assessment. But in Ohio, what does this mean for us? Severe heat is really one of our big issues, especially, again, in those urban centers. Extreme heat is the leading cause of weather-related deaths in the United States. And we don't think about this often, but it's becoming, again, more frequent, more severe. More air quality issues. So 6 Ohio cities are among the 20 worst places to live with asthma. It's not something to be proud of, but it's a reality that we're dealing with here. Stronger and more frequent storms, right? And so not only windstorms, but flooding. And then you get these cascading effects that I think we don't often consider. Flooding increases water contamination, which leads to more GI illness, to rashes, to liver damage, right? So you can take one thing, like getting more extreme weather, bigger floods, bigger winds, and that can cascade into a lot of impacts that, again, are going to hit some of our most vulnerable individuals and communities the most. Emerging infectious disease. So we have these vector-borne illnesses that ticks and mosquitoes like to bring with them. West Nile virus, it first emerged in Ohio in 2001. We have 81 fatal cases in Ohio to date, right? This is a relatively new thing that's just going to keep growing. Lyme disease, we have an excellent researcher here at Ohio State, Risa Pesapane, who studies ticks within the context of disease ecology. Black-legged deer ticks, which are some of the problematic ones, were first confirmed in Ohio in 2010. And this graph is just showing you those annual cases of human Lyme disease in Ohio over time, from about the time black-legged ticks first appeared to this ends at 2019. So again, it would look scarier maybe if I had the last couple years in there. In Franklin County, right? So here we are in Franklin County. I'm going to assume a lot of you might live in Franklin County. Just this last year, Franklin County, the Emergency Management and Homeland Security Office released their new top 10 hazards for Franklin County. All but maybe one of these are climate-exacerbated hazards. Dam and levee failure, disease outbreak, drought, extreme temperature, flooding, erosion, invasive species, severe weather, right? These are climate-exacerbated hazards. So we have experts in our county saying these are the biggest threats. These are the things we need to be worried about and managing for. And under projected climate change, these things will just continue to get worse. This figure next to it is showing global reported natural disasters by type from 1970 to 2022. And again, they've been on the rise, right? Again, one of these associations with climate change. And I mentioned this, but it doesn't hurt to say it again. Who gets hit the hardest? It's the vulnerable populations, right? It's the poor, it's the very young, it's the very old. It's those with mental and physical handicaps. It's those with chronic health conditions. If you are a privileged person who has the money and the resources and the time to avoid these things, good for you, but what about everyone else who doesn't have the ability to do that? So that's all kind of doom and gloomy. So I'm gonna be a little more doom and gloomy before we talk about what we can do about it. Another question people sometimes have is how much warming is too much? Again, relative, I think, what the answer to that question is, but I'll just kind of lay out what we expect based on climate models. So the observed warming that we've seen since the Industrial Revolution, so since about 1900, has been 2 degrees Fahrenheit, right? So we've already seen that amount of warming over the last 120 plus years. The net zero goal for 2050, which came out of the Paris Agreement that under our current administration, the US has joined back in this global effort, is to limit that warming to 3.6 degrees Fahrenheit. So if as a global community, we say we will reduce our carbon emissions to 0 by 2050, what this means is not that we're not emitting carbon anymore, but any carbon we are still emitting, we are offsetting through sequestration efforts, right? So this might be planting more trees to sequester carbon. This might be engaging in agriculture and farmers for less soil disruption, where we can also sequester carbon. This might be through engineered and technological solutions. So it's not that suddenly we don't emit any methane or carbon dioxide anymore, but that we've offset whatever we're still emitting by 2050. Right now, if we don't meet that goal, and if we don't see some significant action in the next 10 or so years, our best case trajectory is 5 degrees Fahrenheit. That's the Pliocene. So remember that eastern seaboard map I showed you? Remember camels in Indiana and forests on the North Pole? That's where we're heading right now by the end of the century without action. And then because there's uncertainty in these models, the worst case trajectory for the end of the century is 9 degrees of warming. And that harkens back 30 to 50 million years ago to the Eocene. So if you want to Google that and see what that looks like. But that comes with drought on 40% of inhabited land. That's half of our known species extinct. That's a pretty catastrophic outcome. It's very improbable, but it's possible. Because in the climate models, right, there's a lot of complexity and there's interactions, and often we'll think, oh, we know how fast the climate is warming and what that means for melting ice sheets, and then scientists are measuring those melting ice sheets, so like, ooh, our models were underestimating what was going on. That's happening a lot faster than we thought it might. So there's always that uncertainty. So whether we can stay closer to that 5 degree versus the 9 degree, whether we can get to just this 3.6 by 2050, it really does depend on not just individual action, but collective global action. So, doom and gloom. Can we do anything about it? Like I said, we don't want to end this talk with fear and anxiety and a feeling of hopelessness, and maybe I'll just hide out until it all sorts itself out, right? We want to see what we can do. There is a lot of energy right now towards building climate resilience. When we talk about resilience, that's both as individuals and communities mitigating climate change, so reducing our carbon emissions, but it's also adapting, because we recognize that even if we shut off all the carbon emissions today, a lot of those emissions are going to be in the atmosphere for hundreds or thousands of years, and the warming's not going to just turn off like that. So we do need to adapt. We do need to think about how to protect people during heat events. We do need to think about these other things that will make these impacts feel not quite as bad in the near term, while we work towards stopping or slowing these patterns in the long term. And that space in between mitigation and adaptation is what we call resilience. And there's a lot of energy and a lot of excitement and a lot being done in this space, right? And so examples of that intersection between reducing our carbon and also protecting especially vulnerable communities from these impacts are things like engaging in water conservation, supporting new energy systems. Again, if you're privileged enough to buy electric vehicles and put on solar panels, go for it. If you're not, there's a lot of other ways you can politically engage to really support policy changes and bigger structural changes. Local foods movements, just educating ourselves about these things, building more complete and connected communities, planting trees, right? These are win-wins. These are things that both offset those impacts from our energy behaviors, but also protect us from some of these concerns we have about extreme weather and other climate exacerbated hazards. So what can you do? So I told you at the beginning, I'm not going to tell you what to do because that would be strange and weird. And also what you can do is going to be specific, right, to you. It's going to be specific to, again, the time you have, how excited you are about engaging in these actions, to the resources that you have. And there's kind of two main spaces I think you can think about moving forward. One is obviously reducing your carbon footprint. There are a million good carbon footprint calculators out there. I think when you Google search that, one of the first that pops up is with the Nature Conservancy. That's a great one. What we do know is the US average footprint is 16 tons. The global average is only 4 tons, but we need our global average to be 2 tons to reach our climate goals by 2050. And so certainly you can go and in a very personalized and tailored way, see where you can make reductions in your own life. For me, one of the things that I can do is fly less. Flying is one of the most carbon intensive activities we can do. Sadly comes with part of my job. So I have to decide, am I going to fly less? Am I going to buy carbon offsets? So at least I'm neutralizing that impact of those flights that I take, right? That's up to me to decide based on my own values. So you can each go and see what are the things where I'm having the biggest impact and what do I feel comfortable trying to tackle. But I want to make sure we think about this too, because there's been a little pushback on the carbon footprint idea, because it really starts to focus just on your energy behaviors, right? It really says, like, what are those things you're doing that are producing too much carbon? Can you cut back on those? There's this kind of shift to talk about your climate shadow and trying to reduce your climate shadow. What does that do? It broadens us outside of the energy and carbon space to things about talking to other people about climate change. Talk to your neighbors, talk to your friends. I have given this talk to my family at Thanksgiving. Because I had a cousin who said, tell me about this climate change thing. And I was like, okay. And I pulled out my slideshow. So talk to people about climate change. Invest your money wisely. Think about divesting from energy intensive investments. Vote carefully, right? Think about our elected leaders and what they're willing to do and support. Engage politically, right? That doesn't have to hardly take any money, just some time. So there's just a lot of things I think we've been doing that, again, we can tailor to how motivated we are, to what our resources are, to what our abilities are. And we don't want to just get trapped in our kind of individual energy behaviors. We want to think bigger than that. And we want to promote these bigger system-wide changes. And we are doing something about it, right? This is a global we. There is a global agreement by countries across the world to reduce their impact to net zero by 2050. What came out of that in the United States is the Inflation Reduction Act. We're investing a lot of money in addressing climate change along with other kind of societal challenges. I'm going to skip past that question mark in the middle. You can see where that's going. Columbus is doing a lot. Columbus has this goal that they're following with the Paris Agreement. 100% of greenhouse gas emissions reduced by 2050. Where we aren't seeing action so much in our locale is in Ohio. So the state of Ohio does not have a climate action plan that talks about meeting these goals. And so if you want to put some pressure on our politicians at the state level, is a good place to do that right now. And if you don't live in Columbus, engage your local leaders in your municipality, right? A lot of this action is going to happen at the local level, and there are still opportunities to do that. So I want to wrap up. I think I have literally 30 seconds. I killed it. I never follow the time constraints right. Okay, takeaways for today. Human-induced climate change is real. Climate change is having, already, has been, currently is, and will have negative impacts on people in your communities and throughout Ohio. We can do and we are doing something about it, but we do need to do more. We all have a lot going on in our lives. We have other priorities. We're busy. We have constraints. And this is a thing that is very easy to put on the back burner. So I just challenge you, if you have a minute, to take the time to learn a little more about it, to start to think about what are the things that you can do, again, within the time and the resources that you have. If you have an hour, go out and talk to someone about it. Engage people in that conversation. If you want to commit a day, show up at a protest or a rally, right? Engage in political action. I have a friend who is very good about having her stack of postcards that she sends to her elected representatives. And once a week, she sits down and just sends off one postcard. These are the things that I want you to be doing for me. I elected you. We don't do a lot of that. And if you talk to folks that work in DC, while we all might have opinions on the contentiousness of our federal government these days, they're not necessarily hearing from people about this, right? And so even that little action of just reaching out regularly and letting our elected officials know it's important to us is a small thing that we can all do. So I also like to end on this, because this is another one of these kind of funny conversations you might have with someone. What if it's a big hoax and we create a better world for nothing? Okay. So I'll end with that. If you're interested, I'll leave this up. There's lots of great resources. The first couple will just, again, provide a lot of what I talked about today, let you dig a little deeper if you want to. The National Climate Assessment just came out this last November, December, the newest one. Our state climate office has a lot of great resources. Climate.gov at NOAA, great resources. While again, I said action is personalized and there's no one right answer to this for anyone, you can go to the UN Actions for a Healthy Planet and get some of those ideas. Happy Climate is a website created by a friend of mine that helps you think about reducing your footprint while increasing your happiness, which is a lovely thing. And then I wanted to mention Catherine Hayhoe. She's a climate scientist out of Texas who has a ton of great resources and talks about how to engage others and how to have difficult conversations and how to identify shared values and ways to even start conversations about things like climate. So if you're excited about that, I would encourage you to check out some of what she has to say. So I'll stop with that. Thanks.
All right, we have time for Professor Wilson to take a few questions. Let me get out of the spotlight so I can see anybody. Okay, here we go. Hat.
Yeah, sure.
Hat.
Yeah, I had a question. You mentioned when reducing your carbon footprint, the concept of buying carbon offsets. That's not something I'm really familiar with. I was wondering if you could elaborate on that.
Yeah, so the question is, I mentioned carbon offsets, and what exactly is that, or how do you do that? So certainly there are choices we might have to make in our life that will have a carbon footprint, especially right now with the way kind of society is structured. Again, I mentioned flying is one for me that I have to make difficult decisions about. So there are programs, some are better than others. Maybe, I'm trying to think, I don't want to get inundated with emails, but email me if you want me to suggest one. I think the Happy Climate website might suggest a particular kind of safe one to invest in, but essentially you are paying for your carbon to be offset through programs. And so it might be tree planting in urban areas and underserved communities where heat effects are particularly large, right? So you're basically saying, like, for every ton of carbon I've produced, I'll pay $10 to offset it through some sort of community program or effort elsewhere to sequester that same amount of carbon. So it's a nice way, I think, if you realize there's just limits to what you can do, but you have some guilt associated with that. The 2050 goal of net zero will not be reached without carbon offsets. Like, that's a reality that even OSU's climate plan involves carbon offsets. And so I think realistically we know it's impossible. And I don't want to say that. Good for you if you're carbon neutral. It's very hard to be carbon neutral without recognizing that you could invest in these sort of offset programs to try to make up for some of it.
Thank you.
Okay, so Young, did you have a question there? Go ahead.
How could plastics and microplastics in the ocean affect the world's temperatures via
Ooh.
destroying the ecosystem?
Okay, the question was about plastics and microplastics in the ocean in particular. I'm not aware of any research that talks about the interaction of microplastics with climate or the impact of temperature. So if that's out there, I'm unaware of it. When you think about plastics, single-use plastics, microplastics in our water, that is a hot environmental issue right now, but I don't know that it interacts at all with climate change. So if you're not familiar with that, there's a lot of plastic floating around in the ocean from our single-use plastic habits. That plastic degrades over time, and we're finding microplastics, or kind of invisible to the eye pieces of plastic in our drinking water, in animals that we consume from water bodies. And there's a lot of research right now trying to understand what impact that's having on us. So it's certainly an environmental challenge that a lot of people are thinking on, but not so much at the intersection of climate change. Good question.
Okay, Grace Witchard.
I want to get your perspective on the 2050 goal. It's so far in the future that I don't think people can relate to it. And a lot of people in this room would be saying, well, how am I going to be dead by then? So my concern is, or do you have a perspective on, is that goal, that stated goal, actually working to defeat progress?
Okay, the question is, we've set this goal of 2050, which feels really, really far away. And some of us might say, I will be dead. So it's a maybe not an appropriate timeline for setting a goal, is maybe what I'm hearing a little bit. I am not aware of research that has looked at, and again, I'm a social scientist, so I actually think about, have we looked at whether or not the setting of a goal that far off is reducing people's motivation to do something about it, right? Or impacting even political will, let alone politicians' willingness. If there's research on that, I'm unaware of it. That being said, as a behavioral scientist, yes, it's a horrible idea. So as humans, our timescales of meaning tend to be about a year. So if I ask you to think about something 2 years from now, 3 years, 5 years, you're going, doop. You've discounted that future at a very high rate. And for environmental things in particular, we tend to discount the future almost 100%, making the future meaningless. So I say all that to say that, yes, if I were running the world, I would not make it a 2050 goal. I think part of the reason for doing that is the changes that need to happen and the things that need to be done are going to take time. But a better strategy might be to say by 2050, yes, incremental. By 2050, we want to get to net zero. But to get there, here's what we do this year. Here's what we do the next year. That would be a better strategy for really motivating people. And another piece of that is what we know about human behavior. And this is like Psych 101 if you ever took a class like this in school. But you think about like Pavlov's dog and getting rewarded for things, right? As humans, if we don't get immediate feedback as to the thing we're doing bad or good, we don't learn anything from that. So again, when we set these far off goals, if we're not tracking that and giving immediate feedback and regular feedback along the way toward that goal, then people will lose motivation to continue over time. So I think there's a lot of ways we can have that goal while also making it maybe a more effective and motivational path. Yeah, good question.
All the way in the back there.
So you didn't mention anything about like CAFOs or like the production and consumption of meat. is that something we should be worried about, or like, should we be changing our diet to be more vegan or vegetarian?
Great question. So the question was, I didn't say anything about CAFOs, concentrated animal feeding operations, or the production of meat. Beef is a big one. Some protein production, animal protein doesn't have as big of a carbon footprint as beef. Yes, that's certainly one of the things you can do. So when you do a carbon footprint calculator, one of the questions will be, how much red meat are you eating? And if you can cut back a little and say, I mean, great, if you want to be a vegan or a vegetarian, good for you. If you're like, I would eat it once a week or 3 times a week, like, I think the important thing is to think about what's realistic for you and what's appropriate. So I will give an example. I have tons of vegan friends. I live in a world of vegans. I am not a vegan. I love cheeseburgers. But what do? I have a friend who has a regenerative ag farm who raises beef, and I buy a quarter of a cow, I stick it in the freezer, and we use it for a couple years. I feel good about that. We choose not to eat it too often. I feel good because I'm supporting regenerative agriculture, which is closed loop, low impact agriculture. And so for me, that's a winning solution to that question. For others, it might be different. So I think being open-minded when you do those calculators as to like, okay, it's telling me I could do less of this or more of that, and then think about what's a realistic goal for you. And maybe it's not cutting something out completely, but it's reducing it or it's sourcing it in a more responsible way.
Lots more questions. Let's go hat in the back.
You talked about some of the differences between states in terms of the impact of global warming. So, like coastal states, flooding, wildfires, and then Ohio you mentioned as a positive, the fact that we're next to the Great Lakes, so a natural water source. Is there a huge differential for how different states in the Midwest are being impacted?
Ooh, that's a good, okay, so the question was, I mentioned that so this is not so much what states are doing, but the impacts of climate change can vary state to state, right? Obviously, like East Coast communities and Southern Coast communities are some of the most impacted on the sea level rise side, just because they're so low. And then the question was, are there differences across the Midwest? They're kind of minimal. So there is I mentioned the National Climate Assessment. We have our state climate office. There's also been a Great Lakes climate assessment. And so a lot of the impacts that we're experiencing in parts of Ohio are similar to the rest of the Great Lakes region. So imagine all the states around, right? Wisconsin, Indiana, Illinois, Michigan. So there's a lot of similarities. When you think about the Midwest, where you start to really see differences in the impact, not even so much from a heat standpoint, but from a water standpoint, as you head further west in the Midwest. So I do a lot of work in agriculture, and we divide the Midwest into the Eastern Corn Belt and the Western Corn Belt. The Eastern Corn Belt is dealing with more frequent and severe rain events and heat. The Eastern Corn Belt is dealing more with drought. So you do see a hydrological difference across the Midwest as you go from east to west, where here it's like too much rain, what do we do with it? As you move further west in the Midwest, it's not enough. So it is a different challenge in that sense. And then rural to urban, I guess I should say, is the other big thing, right? So it's not so much the states, but heat is just a much bigger issue in urban areas than in rural areas across the board.
Go ahead, ma'am.
Thanks. I'm wondering if could you talk a little bit about educating children about climate change? Because are there people working on, like, say, best practices? Just, I've noticed that, like, it's either not talked about or, like, in children's books when it's talked about, it's a real downer, and I'm really worried about paralyzing children, and I've personally seen some young adults get just really depressed about it.
So the question is engaging children and educating children about climate change without it being overwhelming or depressing or scary or existential crisis inducing. I think that's a real problem. I think we see that amongst a lot of the kind of teenagers and young adults that we engage at the university, that there's a real fear and a frustration with older generations for creating problems they have to solve, but a real fear, and that can be paralyzing. Off the top of my head, I cannot think of a great resource to point you to. I do know that at NOAA, they do have some really great kid-friendly resources around community engagement and adaptation. And so that might be a way to engage children, is to start to think, and I even do this in rural communities that I work in, where there is some greater than the rest of the US doubt around the human caused part of climate change, but there is embracing of the fact that the climate is changing, that we just talk about adaptation, because that is the challenge in agricultural communities, is dealing with the drought and the heat and the big rains in the spring when they don't want them. So we start by having that conversation. And there's really great research that shows if you can engage people around what's happening locally and impacting them, that even without talking about mitigation or even getting into that question, people actually go home and adjust their thermostats. So there's these cool like spillover effects that if you can engage people around impacts and how we can take action to minimize those impacts, it eventually kind of positively spills over into their energy behaviors as well. So my gut would say is maybe engage children around community resilience and those sorts of things that are going to make the impacts less significant, but also start to build our longer term resilience, and that might be a safer space to start. And if you reach out, I could send you the link to the NOAA work. It's good, or maybe if you Google, you can find it.
Okay, we'll take one last question here.
I think one of the scariest things I've read is that the oceans are absorbing about the heat equivalent of 7 Hiroshima bombs per second. So my question is, we know the oceans are getting hotter, we know it's going to kill fish, et cetera, but of course that's also going to create water vapor. We know that water vapor and clouds are cooling gases. So my question is, do any of the models account for more clouds, more solar reflective elements back into space, which might have a cooling effect? Of course, the fish will all be dead.
The fish will be dead. Okay. The water is boiling, but do we know if it's going to cool the long-term trend? I don't know. So I do know that our climate models do account for those sort of like offset cooling effects to some degree. To what extent they're accounting for that sort of complexity, I'm not 100% sure. I would recommend the state climate office as a good resource for that. Dr. Robyn Wilson is our state climatologist, and I work with him on projects where he's the climate modeler. So I bet he would be able to very precisely tell you if they're accounting for that sort of complexity in the system. But I think that's our real challenge, is when I gave that 5 to 9 degree future at the end of the century, the reason it's 5 to 9 degrees is exactly that. That is why they can't say by 2100 it's going to be 7 degrees or 5 degrees or 9 degrees, because there is a lot of complexity. And as things change, there are sometimes these unexpected interactions that are not always accounted for in the climate models. The trend has been that we are underestimating the effect. Every time we realize the models aren't quite right, it's because they're a little too optimistic or too cautious. Rarely have I seen it go the other direction. But I would defer to the climate scientists on whether that specific piece is captured.
Okay, I just have 3 questions for the audience. One is, I hope you've signed up for the Science Sundays email list. You get about 1 email per month to find out about talks like this. So that's the first question. The second question is, would you like to go upstairs and relax and have a cookie?
Yes.
And the third question is, would you like to help me thank the speaker?
Thank you.